Hello, everybody. This is Jason Hintersteiner from LigoWave. Thank you for attending today's LigoWave webinar. Today's webinar is Solving the Road Warrior's Dilemma, LigoWave's guest access solution, and we're going to talk about hospitality Wi-Fi in general, some best practices for hospitality Wi-Fi, and LigoWave's new guest access solution for facilitating guest access in hospitality and other hotspot environments. If you have questions, please post them to the questions tab through webinar, and we'll leave some time at the end to go through them. So this is a little bit about me. I'm the Director of Business Development for LigoWave Networks. I'm based in Canton, Georgia in the United States. I'm a veteran in hospitality Wi-Fi. Over the course of my career doing wireless networking, I've designed, deployed, and or been involved in troubleshooting for literally hundreds of networks utilizing Wi-Fi and point-to-point and point-to-multipoint. I've worked for both service providers and for network equipment manufacturers. I'm also a frequent traveler, so I'm subject to having to live with hospitality Wi-Fi a lot when I'm on the road, visiting customers and attending conferences and so forth. I'm also a certified wireless network expert, which is a vendor-neutral certification from CWNP, and what it means is that I know an awful lot about how Wi-Fi works. So today, as I mentioned, we're going to start with a very brief overview of LigoWave, who we are. I'm going to talk about the challenges of hospitality Wi-Fi. What are the common requirements and constraints in this vertical, as well as our typical best practices for deployment. I'll give an overview of our Wi-Fi products, the LigoWave NFT series, and then we'll spend some time diving into the new guest access features that were just launched a couple of weeks ago in our Infinity Cloud Controller. So some key facts about LigoWave. We were founded in 2007, so we're 12 years old. We have a global presence. We sell across 100 countries. Actually, we're close to now 150 countries worldwide. We have R&D in Europe. Our production is in Asia, and we have customer support and sales in the United States, Europe, and in Asia. So we sell on, I don't think we sell to Antarctica, but we sell on all other 6 continents. We have a very diverse selection of products that break down into 3 main categories. We have our enterprise point-to-point and point-to-multipoint backhaul, and this is primarily for operators, municipalities, carriers, oil and gas fields, internet service providers, and so forth. Basically anything that is what we call multi-mile or multi-kilometer. So anything that's going far distances are typically going to be using our enterprise point-to-point solutions. We also have a line of SMB point-to-point and point-to-multipoint products that focus on short distance, sub-mile, sub-kilometer applications like surveillance, access control, digital signage, building to building, audiovisual, and even elevators. We've had separate webinars on how to do elevator Wi-Fi. And of course, we have indoor and outdoor Wi-Fi products for multi-dwelling unit properties like apartment buildings and hotels, obviously, for hospitality, student housing, hotspots, and so forth. And that's what we're going to be talking about today. Some of our core competitive advantages, performance and protocols, especially on the point-to-point, point-to-multipoint. We have some proprietary protocols that allow us to get some faster speeds. Cloud monitoring and management of both Wi-Fi and point-to-multipoint. So other vendors have, everybody has cloud management on Wi-Fi. We have it on both point-to-point and point-to-multipoint as well. We have what's called architected simplicity, so we have very intuitive user interfaces. And as you'll see later, as we walk through building up your guest portal, you'll see that it's pretty intuitively laid out and pretty easy to program. We support mesh on all of the Wi-Fi access points. First and foremost, though, we have no ongoing support fees or licensing costs. Once you buy the product, it's yours for the life of the product. You don't have to pay anything in terms of support. Support is free for the life of the product. Firmware is free for the life of the product. Standard 2-year warranty on all hardware. We also have pre-sale design services and customer support. So you can get us on the phone, and if you have a project and say, hey, how many APs do I need? Where do I need to put them? How should they be set? That's something that we can help you with either prior to purchase or even after purchase when you're setting up. And also, of course, high reliability. So I'm going to skip over this quickly, but basically you can get to us in a number of ways, including live chats, ticketing, email, and phone. It's very easy to get live technical support from a real human being that's a LigoWave employee. Our pre-sale design services, I'm the CWNE on staff. I'm based in the US, but I cover worldwide. We also have certified wireless network administrators on staff. And for link planning, we have a free online link planning tool called LinkCalc at linkcalc.ligowave.com. I encourage you to check it out. Cloud monitoring and management, as I mentioned, we have cloud management for both point-to-point, point-to-multipoint, and Wi-Fi. We also have public and private cloud options available. We're one of the only companies that gives you the choice of whether you want to use the public cloud or the private cloud. You're going to see with the guest access, you must use the cloud controller in order to use the guest access features, but these features are available in both public and private. So our controller options, you can do privately hosted. So this is an on-premises controller. So basically one AP acts as the master AP. You cannot use the guest services with this. So if you want to use the guest access services that we recently added to the controller, you must use either our public or private cloud. The rates on the public cloud are very inexpensive. They come out to like 69 cents per AP per year for a 100 AP plan. For the private cloud, there's obviously no charge. You can download that for free. But then, of course, you have to host it and pay hosting and bandwidth costs on it. We also have our premium cloud service, which is essentially a branded cloud service for OEMs and operators and large enterprises. We can also do some customizations and some additional product features here. And that price on that would be dependent on the level of effort and changes that need to be made. We also have a partner program. So we have a partner portal for accessing all of LigoWave's marketing materials, specs, and data sheets and so forth. You can get access to promotions directly from us, deal registration, channel management, price protection for projects and integrators, and our online knowledge base. So if you're interested in any more of that, please feel free to contact us at support@ligowave.com. Let's dive now into the subject of today's webinar, which is hospitality Wi-Fi. So the key challenges are, of course, the guests. You know, Wi-Fi would be easy if it weren't for the users. But of course, the client population is, of course, what's driving Wi-Fi. And there are some unique challenges within hospitality that you don't necessarily see in other verticals. First and foremost, the client devices are literally changing on a daily, or perhaps more accurately, nightly basis, where every night I have a new set of guests with a new set of devices, and I'll have to be able to support all of these different types of devices getting on my network. And you know, if I have problems with a device and I need to spend a whole bunch of time getting it online, maybe I'm only doing that for a night or two, and then I have to go through the whole process again. So we need to make it very easy to get all sorts of different clients on board. We also have multiple client devices per room. As a business traveler, I'm traveling with my laptop, my tablet, my Kindle, you know, my phone. So I've got, you know, 4 devices just for myself. You know, then if you have a couple or a family traveling, you could easily have, you know, 5, 6, or even, you know, 10 devices per room. Typical average on a room is probably around 2 to 3 devices per room per evening. Plus, you know, it's not just simple applications. 10 years ago, people were just hooking up their laptops to check email or surf the occasional website. Now they're streaming Netflix within your hotel. And they expect the performance of it to be like what they get at home. Well, of course, at home, you know, they're only sharing it with their family. They're not sharing it with 300 other strangers, you know, in a small hotel environment. So it could be very challenging to provide that same level of service that they expect at home within a hotel environment. And it's incredibly complex. So, and it's also incredibly competitive. So in hotel reviews nowadays, the ability to connect to Wi-Fi is often rated more highly than things that you might expect, like clean sheets and clean towels. So And if you don't have working Wi-Fi, well, then you're going to, as a hotel operator, you're going to lose customers to your competition across the street, because there are usually lots of hotels in town, and they don't have to be staying at your place. They'll stay at someplace else, even if it's a little more expensive, because they can get on the internet there. So those are the challenges that we face when we're designing hospitality Wi-Fi. As I mentioned, client devices literally change on a nightly basis. So you have that constant barrage of new and unknown devices using your network. So let's talk a little bit about requirements of hospitality Wi-Fi. So let's break this down a little bit. So first, let's talk about usage. When we talk about hospitality Wi-Fi, we're usually thinking about guests getting online, but guests are not necessarily the only users. You may have other applications on the network as listed below, back of house operations. You might have voice over IP or voice over Wi-Fi. You may be delivering IPTV. You may have public restaurants in your hotel that have their own Wi-Fi. You may have IoT devices, so to make your smart guest rooms in order for you to open the blinds and to turn on and off the lights and so forth, to control the temperature. And then in some environments, the staff have panic buttons to ensure that if the staff run into trouble, they can communicate. And all of that's happening on the Wi-Fi. So when we talk about usage of hospitality Wi-Fi, it's primarily for guests, but it's not always about guests. And there may be other applications going on the Wi-Fi. You also still have modern 2.4 gigahertz only client devices. So not all of your clients will be dual band, which means that you actually still have to design for 2.4 gigahertz as well as for 5 gigahertz, because you will have some class of client devices, even brand new client devices that are still only operating on 2.4. And especially if you're doing anything with IoT or smart guest rooms, all of that stuff is on 2.4. For guests, you need client isolation within and between access points. You do not want the guests talking to each other. You do not want a guest in one room hacking into the device and stealing data off of a guest in another room. So it's important to make sure that client isolation is available as a feature so that guests can all get out to the internet, but that they can't see each other. You will need a captive portal to control access. Usually you don't have encryption like a WPA2 key on the Wi-Fi, but you will control access to make sure it's only guests and not somebody sitting in your parking lot. And you'll do that with a captive portal, and that's what we're going to talk about for the guest access features in a few slides. You may or may not have to integrate with the property management system. So, that's the types of things that you have to worry about in terms of usage. In terms of coverage, because you may be using your network for staff operations and for point of sale operations, like in your restaurant or in your lobby, or for the maintenance staff or housekeeping staff, I'll have to worry about both front of house and back of house. So front of house is anything that's guest facing. So those are your guest rooms, your restaurants, your lobby, any conference facilities or banquet facilities you have, all of that's facing the guests. And then you have your back of house, which is all of your internal operations. So your kitchens, your point of sale, your offices behind the front desk. So all of the stuff that's going on in the background that the staff sees, but the guest does not necessarily see. And you need to cover both of those areas. And you also may need to cover both of those areas differently. For example, I'm not going to provide guest access in the kitchens, nor do I necessarily want to provide point of sale access on the guest room floors. So you need to not only figure out, where your customers are and who your customers are using, but where they're going to be using your different classes of customers, your guests, your staff, security, where all those devices are going to get used, because those are not necessarily always the same places. I also have to worry about capacity, because if you have conference centers or if you have banquet halls, you're going to actually have very high usage during events, and so you're going to have a lot of people packed into a very small space. And as I like to say for conference centers, right, the usage of the Wi-Fi is inversely proportional to the interest of the presenter. So if the presenter is interesting, people are listening and they're not on their phones. If the presenter is boring, everybody's on their phones. And you'll see a surge in the Wi-Fi usage as a result. You also still have moderate use, by guests in the guest room because of in-room video streaming and Wi-Fi phone calls. Now, your peak usage time in the guest rooms are going to be evenings and weekends when the guest rooms are occupied. In your conference centers and banquet halls, though, it might be during the day when you have events going on. In terms of monitoring and control, typically a hotel is not doing this themselves, but they're usually working with an outside wireless internet service provider. Depending on the franchise, depending on the hotel chain, they may dictate what AP vendors you get to use and what WISPs you get to use. Some chains do this, some chains do not. Some chains will just give you a list of requirements and then say, okay, you can use whoever you want so long as they meet the requirements. You may need multiple VLANs because not only for the different applications, but your different applications may be provided by different service providers. So often your telephone service provider, your TV service provider, your back of house and point of sale service providers may all be different vendors, all of whom are sharing the wireless and the wired network infrastructure. And so it's typically you have somebody responsible for the network, but the network isn't necessarily just being used by one vendor, and that can complicate integration tasks. So, and then of course, cloud management tools are essential for monitoring. But the key thing here is to expect to have to deal with many different players with different and perhaps even conflicting interests for your router, switch, and Wi-Fi infrastructure. And finally, you have your integration or your physical infrastructure. You may or may not have wired Ethernet ports in each room. You may or may not have dedicated IDF closets. I've seen so many IDF closets that are shared with storage closets or maid closets or other things, and that's where they can stuff the switches and so forth. But that can mean that wires can get knocked out accidentally or power can get switched off, so you have to worry about those things. And if you have multiple buildings, if you have a hospitality environment where you have multiple buildings, you may or may not have the fiber or Ethernet infrastructure to connect the buildings, and so you may need to do wireless links between your buildings. At the end of the day, though, we talk about wireless, and when a user is having problems, they complain it's the Wi-Fi, but your wireless network can only be as good as the wired infrastructure that supports it. So the cleaner that your wired infrastructure is, the cleaner that your MDF and IDFs are kept, and that your wiring is kept under control, the better your network will perform overall. So we should also talk about constraints, because that will often dictate what's going on in the design and basically how well you can satisfy those requirements. First and foremost is budget, right? Nobody has infinite amount of money to spend. You have aesthetics concern. Many high-end hotels are very concerned about how the APs look, and they don't want to have anybody see any APs, and aesthetics are often more of a requirement than actual functionality. So they want to hide the APs behind walls or above ceilings, and that will degrade the performance of the Wi-Fi and the user experience. But sometimes that's just what you have to deal with. Mounting restrictions and wiring infrastructure. If you have cabling in rooms, great, but especially on older properties, you're not going to, and you're not going to be able to get cabling into rooms, and you have to deal with that. If you're in a crowded urban or suburban environment, you may have external interference from neighboring buildings. And then you may have co-located systems for other parts of your hotel or hospitality environment that are using the same frequencies. So radio systems, cordless phones, that type of thing, where you're going to have to work around the interference created by a co-located system. So keep in mind that when you're designing this, the constraints can often dominate your requirements and may dictate ultimately, how well you can actually satisfy your core requirements, which is users being able to get on the network in all of the locations. So now let's talk about design. So typically, because of your aesthetic constraint, even if you don't have harsh aesthetic constraints, nobody likes to see antennas anymore. So you're almost always going with indoor APs with internal antennas. If you have APs in the rooms, if you have wiring in the rooms, you can often place the APs over the existing Ethernet wall plates. Keep in mind, you don't necessarily need one AP per room, and I will show that momentarily. Very often, for most hotel environments, APs rated for SMB applications are quite sufficient for guest rooms. You don't necessarily need to go with high-end Fortune 500 rated large enterprise APs for a hospitality environment. They'll have a lot of extra costs and a lot of features that you don't need and won't be using, but you'll be paying for. So make sure you understand your requirements and that you're picking your AP to match your requirements. Unfortunately, in this business, many WISPs will pick the AP models and vendors that they're familiar with, not necessarily the models and vendors that are most appropriate for the requirements, and that can lead them into trouble. So after you've selected your APs and what APs you're going to use, you need to figure out where you're going to put them. The general rule on placing APs is that they should be as close as possible to client devices and as far as possible from each other. So what does that mean? That means what happens is that your client devices have much weaker transmitters than your access points. So if your access points are cranked up to top power, I can, even with a lot of structure in the way, so they're coming from the hallway and they're going into the rooms and they're going through a few walls, because they're shouting really, really loud, the client device can still hear them. The problem comes in is that I have a phone with a much weaker transmitter on it that is now trying to talk back to that AP. It has to traverse those same walls and the same barriers and so forth, and that could make it very difficult for the AP to hear the client device in response. So the general rule of thumb is I want as few obstructions between the access points and the client devices as possible. I want to place the APs as close as I can get them with as few obstructions as possible to the client devices. That said, I don't want the APs talking to each other, and I have a limited set of channels I can use. So I want the APs to be placed as far apart from each other and with as many walls and obstructions as possible between neighboring APs, because that will facilitate my ability to reuse channels. At the end of the day, what this means is that in-room deployments are always or virtually always better if you can do them. And I will show you that on the next slide. So what you're seeing here on the left is a floor of a hotel where the APUs are deployed in the hallways. And you see on the top row is your coverage, and the bottom row is your co-channel interference or your channel overlaps. When you deploy APs in the hallways, I've got great coverage in the hallways, but I've also got a lot of interference right at the APs, which is going to make it difficult for the APs to hear. And I don't necessarily have great coverage in all the rooms because of the structure of the bathrooms and the physical walls of the hotel. And if the walls are made of concrete or brick as opposed to drywall, it's only going to be even worse. Now contrast that with what's going on the right, where the APs are placed, generally every, in this case, 3 to 4 rooms. So it's roughly the same number of APs, but I've got the APs as close as possible to the client devices. They're not passing through bathrooms. They're passing through kind of straight walls. But there's a lot of structure between the APs, so that as I need to reuse channels, there's very little co-channel interference. And as a result, you're going to wind up getting much better performance out of the network on the right than you will on the left. Now, you can't talk about deploying Wi-Fi without talking about channelization. And when you're looking at your throughput per user requirements, typically, even these days, you're looking at 5 megabits per second, 10 megabits per second. I've seen hotels that are even doing 20 or 30 megabits per second per user. And quite honestly, 20 megahertz channels are quite sufficient for that. You don't need bigger channels for that. The bandwidth limitation on your network should be your bandwidth coming in, your internet bandwidth coming into the property, because that's your most expensive component. And typically, you might have a 100 meg cable circuit, or you might have a couple 100 meg fiber circuit coming in. If it's a large hotel, maybe you have a gigabit or more fiber circuit coming in. But remember, you're dividing that amongst lots of access points and lots of users. So you generally don't actually need the larger channel sizes on the Wi-Fi, and you want to use smaller channel sizes so that you have more channels to pick from, and that will minimize your self-interference and make sure that the people on those channels are actually communicating cleanly. You never ever want to use 40 megahertz channels on 2.4. The whole band is only 72 megahertz wide, so if you're using 40 megahertz channels, you can't even get 2 independent channels on that band, and you need at least 3 in order to kind of keep things independent, with more channels making it easier and better. So even on the 5 gigahertz band, you generally want to be using 20 megahertz channels. I'm a big fan. We have auto channel on our APs. Most other vendors do as well. That said, I'm a big fan of turning off auto channel and just using alternating static channel pattern on both bands. You will also want to implement band steering so that you have all of your as many clients as possible connecting on the 5 gigahertz band, where generally there's less interference, less noise, more channels available, and you leave the harder to work with 2.4 band for those client devices that are 2.4 only. So, for a Wi-Fi deployment to be successful, you need to avoid or at least minimize the self-interference between neighboring APs, and you do that by staggering the channels. You also have to worry about the transmit power, and I alluded to this earlier. If your AP power is too high, you can create a false sense of coverage because the AP is screaming at the top of its lungs. So the client device will hear it very well, even with walls in the way, or even at a very far distance. However, the client is whispering in response, and clients have much weaker transmitters in order to preserve battery life. So phones and tablets are notorious for having very weak transmitters, and that's done on purpose because transmitters take a lot of energy. And if I use a lower power transmitter, then I'm sucking up less energy and my battery will last longer. Keep in mind also that 5 gigahertz will attenuate faster, even in open air, but especially as it goes through walls and other objects and furniture and so forth. But when I place a dual band AP, I really want the same coverage area to be on both bands. I usually recommend a static offset of at least 6 dB between the 2.4 gigahertz and 5 gigahertz. So I usually start with 14 dBm at 2.4 and 20 dBm at 5 gigahertz. So key message to remember here is that you're not designing for the APs, you're designing for the client devices. And when you're locating APs and you're setting the channel power, what you're really doing is you're not facilitating the AP's ability to talk to the client. You're really facilitating the client's ability to talk to the AP. And it's a little bit counterintuitive, but that's really what you're doing in a design. I'll also recommend that you don't do what we call Dixie cup designs, which is, okay, I'm going to place an AP and I'm going to draw a circle around the AP, and that's my coverage. And hey, we said 5 gigahertz covers less, so I'll use the base of the Dixie cup for 5 gigahertz, and I'll use the wider circle for 2.4 gigahertz. Don't do that. I've seen so many integrators do that. There is actual commercial software available to do predictive modeling, as well as passive and active surveys where you actually walk around and you actually take readings of the APs in the environment. I highly recommend, if you're doing this all the time, invest in one of these packages. Ekahau is shown here. There are a couple of others out there on the market. If you need assistance with this, we actually provide predictive design modeling for free for these types of projects. So if you have a hospitality project and you're like, okay, how many APs do I need? What room should I put them in? How should they be set? Come ask us, call us up, send us an email, and we will do that modeling for you, and we will tell you, okay, here are the APs you should use, where you should put them, what the critical transmit power and channel settings are. So if you need assistance with that, please ask, because we are equipped to be able to support you in that. I mentioned earlier that often you're going to control who gets on the network via a captive portal, because you're typically not going to give out a WPA2 passphrase to every guest that checks into your hotel. So what happens is with a guest access is that you typically have an unencrypted Wi-Fi network, but then you're controlling access to the internet with some type of captive portal, which is a splash screen that basically says, hey, okay, you're allowed to get on or you're not allowed to get on. These come in both standalone appliances, or as you'll see, we now can manage this through the AP Cloud Controller. The user gets a splash page and at a minimum has to acknowledge terms of service. There may be vouchers or additional codes, username and passwords, stuff to be put in, and there are several different options depending on your scenarios. The problem, of course, with captive portals, there are a couple of problems with captive portals. One is devices without browsers, so often things like Kindles, for instance, or Xboxes or other types of appliances typically don't have an embedded browser, and they'll have trouble getting past the splash page. You can MAC authenticate devices so that they get straight on, but it makes life a little more difficult. Most captive portals also just tend to not be designed very well, and I've stayed in several hotels where you have to click through several screens in order to just get online. And then if you're offline for 5 minutes, you got to do the whole damn process all over again. It can be incredibly frustrating. You'll see though that with our solution, we've made it as easy as possible to not only build a captive portal, but as easy as possible for the user to just get online with something simple and straightforward. Your common login options, the two in hospitality terms and conditions, where you just say, hey, yes, I agree, I'm not going to go hack the NSA or the FBI or Interpol or somebody like that. And you check the box for a whole bunch of conditions that nobody ever reads, and you get online. That's the simplest. In a hospitality environment, you may use vouchers, you may use room numbers and like a user code. In apartment complexes, you may have a username and password. There's also social media and email and advertisements and integration with property management systems. Those last few are those that we're going to be adding in later releases. But you could do quite a lot just doing terms and conditions and room numbers and user codes and so forth. And also the users get MAC authenticated in our system so that once they log in, they actually stay logged in for a certain period of time. So if they say leave the hotel to go to dinner and come back afterwards, the device will be recognized for typically for about a day. The device will be recognized if it logs on within the day. You won't keep getting bugged with the splash page. And captive portals are very, very common in hospitality environments. You will see them in most hospitality environments. So let me talk briefly about our Wi-Fi access points that support guest access. We use these in all sorts of different environments, especially in different types of hospitality environments, as well as enterprise Wi-Fi, education, healthcare, and public hotspots. And hospitality, public hotspots, as well as just even apartments and student housing and such are very common applications for guest access. We have APs that are dual band. They support both 2.4 and 5 gigahertz. You can get models that can support over 200 users per access point. So we'll commonly do those in those conference center environments where we may do the smaller APs on the guest room floors where you're really only going to have maybe 10 to 20 maximum simultaneous client devices at a time. We have outdoor APs that are IP66 or IP67, depending on the model. Typical recommended range, everybody always asks, oh, how far can the AP cover? And the answer, of course, is it depends on the walls and what the walls are made out of. Typical guidelines are going to be in the 1,500 to 2,000 square foot, area, so kind of a 100-meter or 75-foot radius, but it's very much dependent upon the environment. We have cloud monitoring and management, and you can also have a master AP to do an integrated controller for small sites. This is just showing some of the models that we have. ranging from a single band 2.4, which I do not recommend for new deployments. Our two most common are the 2AC and 3AC Lite. And then we have a couple of outdoor models as well. To show you that we know where we're putting our money where our mouth is, we have a very large deployment in Florida where we have over 2,000 NFT 2ACs spread across 23 different resorts in and around Panama City, Florida. We actually displaced another vendor in these environments, and you could see the testimonial of the franchise owner. So we have over 2,000 of these now deployed across all of these resorts in Panama City, Florida, as one of several examples of hospitality deployments. So let's talk about guest access via the Infinity controller. If you're already a LigoWave user, you probably already have a controller account, either public or private. If not, just go to controller.ligowave.com and create an account if you don't have one. It's free for the first 10 APs to give you a chance to kind of try it out and kick the antennas, proverbially speaking. After you've established an account and logged in, you'll see in the upper right-hand corner, you have an organization ID. You're going to want to keep note of that because you will need it later when you start associating access points, so that the access points know who they belong to. So you're going to go in and you're going to create your network, and before you even create your network, you're going to create your guest access portal. And we have 3 different types of portals that you can create. There's free access, which is your kind of classic terms and conditions, where a user just has stuff that they have to agree to. They have to check a box, and then they click a button that says log in. You have private access. This is for usernames and passwords. We can also use this for doing like room numbers and user codes, and I will show an example of that. And then we have vouchers, where a user is provided a temporary credential. So typically in like hotspots or maybe for conference centers and hotels, you'll have essentially vouchers are usually used for timed access. So maybe they're good for an hour or for 6 hours or a day. So in your hospitality environment or in your hotspot environment, you'll get a one-time use code, and that code is good for your device for a certain amount of time. Now, so you're going to create these different portal profiles for your networks. Note that an individual portal profile can actually support multiple login methods. So on most guest networks, you're going to typically have one and only one of these. But there are scenarios where you may actually support, say, a voucher or a username and password. So, for example, you might have an apartment complex that has that you have permanent login accounts, your permanent usernames and passwords for residents of the building, and you have temporary vouchers for guests and visitors that are for a limited time. You could see that in hospitality environments sometimes as well, where you may have vouchers for the hotel, restaurant, and bar, and for the conference area, and username and passwords for the guest room floor. And you can actually have a splash page that supports either enter your username and password or enter your voucher. So you can create profiles that are mixed for those types of use cases. But I'm going to talk about the individual profiles. So for the free access for terms and conditions, there's really nothing to configure aside from the splash page. For private accounts, you'll create a profile with a private account. You'll go into the private access tab, and there you can actually create all of your usernames and passwords. You can also enable or disable individual accounts, and passwords can be randomized. So you can actually just create an account and just hit we have a randomizer built in, so you can just click it and it'll generate just random passwords. If you have vouchers, you could go to the vouchers tab. You can click generate vouchers. You can generate as many vouchers as you need, 100, 1,000, however many you want. You specify how long you want those vouchers to last in terms of days, hours, and minutes. And then you can export the vouchers to a CSV file, so then you can import that to be able to give them out to individual users. You can also go in later on and you can also delete individual vouchers. If you want to invalidate them, you can also go back in and export some or all of the vouchers later on if you wish. One of the nice features that we have within is that you can actually design your splash page right within the controller. And everything on the page that you see is fully configurable. And it's all HTML5 based, and it's a responsive design, which means that it will adapt automatically to different size screens. So here you're seeing two examples. On the left is kind of the default that you would see for simple terms and conditions. This is what would just kind of come up by default that you can manipulate. On the right, you can see, we've added a background image. We've changed some text. We've changed the login method to room number and access code. We've changed the label on the button. So all of these things you can control. And in fact, here's the full list of things that you can control. I won't read this in detail, but basically, you can control font size, text color for everything. You can put in a background image. You can change the background color. You can add your own logo for your property and change its size. And then you can change the texts for the username and password fields and the voucher fields. You can change what that text reads. So you have a lot of flexibility in terms of what your splash page looks like in a very simple, easy to use interface. The splash page that I did here on the right literally took me 5 minutes to do. You load up your background image, you load up your logo, you change your text, boom, 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 you're all done. So very simple, very easy to use. Once you're ready to test it, you test it with a device. If you say, hey, it doesn't look quite right, you go back in, you make some changes. Right, it's very, very easy and very intuitive. You don't need to know HTML or any other fancy programming in order to code it. It's very simple and intuitive. Once you've got your profiles created, you're now going to go in and create your network. So you're going to go to the network screen, you're going to create a new network, and you're going to say, okay, product series is NFT, that's our Wi-Fi access point. You're going to want to auto-register new devices. And for network type, we've added a new network type called guest access. So it's very similar to our bridge network type that you may be familiar with from before, but you're going to specifically want to select guest access, put it in a parent group, and click on create network. This slide basically just summarizes what I just told you. Once I'm in there, you're going to actually configure your wireless settings. So you're going to turn on band steering. I'm going to set my band steering mode to prefer 5 gigahertz. So I'll edit my available channels. You can enable or disable airtime fairness, which was also new in this release. That basically means that slower clients get responded to less often. And what that does is, so if you have a mixed mode of client devices where you have some modern, 802.11n devices and some older 802.11bg devices, the BG devices get responded to less often because they'll take up more airtime. And it frees up some more airtime for the faster devices to just get on and off quicker. Under channels, right, this is where you're gonna set 1, 6, and 11 and select your 20 megahertz channels for your Wi-Fi. You can go in later and then change individual channels on devices to put your static channel pattern in. But for the profile, you're gonna have it set to auto. All right, this slide just summarizes all of that. So you're now going to click on the Infinity SSID and you're going to edit the network. And there's a slide missing here, but on the main tab, you're actually going to select guest access and you will select your profile on the main screen. On the advanced tab, you can actually enable client isolation to make sure your clients aren't talking to each other. And you can also impose upstream and downstream bandwidth limits on your individual users. If you need to configure individual additional SSIDs, you can click on the virtual AP button and add a virtual AP. So this is going to be your additional, staff network, point of sale, security and surveillance, or so forth. And all of your non-guest SSIDs should really be assigned to a dedicated VLAN to ensure that they're isolated from each other within the network. Now I'm going to add an AP. So you log into the first AP that's going to be on the network. Now, because you said auto register devices, it will take the lead from the first AP, but for the first AP, you got to log into it. You're going to agree to the terms and conditions for the operating country. And then on the setup screen, you're going to say, yes, I'm administering this AP from the cloud. So you're going to click that middle button that says Cloud AP External. That will bring you to a screen where you add your organization ID and your controller URL. If you're using the public controller URL, if you're using the public controller, it's just controller.ligowave.com. If you're using the private, then you would put your IP address or your FQDN for your controller name. Then you're going to put in your organization ID, which I told you at the beginning to remember, but you could always go back and just look it up. One thing for guest access is that all of the APs need to be on firmware 7.63 or later. That firmware was just released within the last couple of weeks. If your APs are not, as you can see, the AP I have in this example was on 7.54. It hadn't been touched. There'd been one in my lab that'd been sitting on the shelf for a year. So I had to upgrade the AP. Once you upgrade the AP and you've added that information, back in the controller, you'll actually get an alert saying, hey, I have devices that need configuration. You basically click on that, and you say, okay, here's the AP. You check the AP, you say, this is the network I want to add it to, and then boom, it downloads that configuration to that AP. And then, pick up your mobile device and now try it out. And here you see, we've set up the LigoWave bed and breakfast with asking for a room number and an access code, which is set up as a username and password. So the username is the room number, the password is the access code. And I can see, hey, okay, this is what it looks like on my, on my wireless device. Punch in your code, make sure you can log in, and when you log in, you'll get a success indicator. And if you go back and you look now on the bottom, you can see here, after I've logged in, you can see the users that are actually logged in with the credentials and their client MAC address and when their session started. So in addition to kind of looking at the devices and who's logged on onto each AP, you can also look at it from a captive portal standpoint, saying, okay, show me all the list of users that are logged in. It'll give you the full list of users that have logged in. And that's it. So in conclusion, you want to understand the key requirements and constraints of your hospitality environment. Hospitality Wi-Fi is mostly, but not entirely, about the guest experience. There's a big difference in performance between in-room versus in-hallway deployments. You always want to design your network to maximize the performance of the client devices and minimize the self-interference between your APs. And in order to do that, that means you got to set your AP channels and your transmit power levels appropriately. And then, of course, finally, our Infinity Controller guest access feature makes it really easy to generate a splash page, support multiple different types of login types, and customize it to fit you or your client's needs. And anyway, thank you very much for your time in today's webinar. I hope this was informative for you, and we'll make the recording and the view graphs available. Email us at support@ligowave.com. So thank you very much.